Hey guys, welcome to Unit 10, Section 5. Today we are talking about cones. This is one of the last objects that we have to go through. So remember surface area, total area of all faces of the three-dimensional object, and then the volume is the space taken up inside of the actual object. So now a cone, a common thing that we think of with a cone is the ice cream cone is the most common one that I think of. It's got a circular top, so it's a circular base and a vertex not in the same plane as the base. So it's kind of like a mixture of the cylinder and the pyramid. So we have that circular base, but all of the curves to it are going to meet at a single point. Now, since it has a circular base, we're going to see a lot of the same things that we did with the cylinder formulas. So we have like pi r squared and pi r, because to find the area of the base, that's what we're going to have to do for the first part. That's the pi r squared. And then the pi r times slant height is going to give us all of the outer sections of area. So with this one, I apologize, the box is a little deceiving here, but this should say 10 feet and then 6 feet for the radius. So the surface area is pi times the radius is 6 plus pi times radius again, and then the slant height here is 10. I'm just going to write it down here because it's bugging me. So the slant height is this part here, not the height. So we have to be careful, just like with the pyramid, for the surface area we want the slant height. So that's going to be times 10 as well. So then we type this in our calculator. Actually, let me grab the other calculator. Okay, so we have pi and it comes out to be 301.59, and this is going to be feet squared because we're talking about area. So pretty straightforward, as long as you have the slant height, you don't have to solve for it. But as you can probably guess, if you see this outline here, say we're given the height and the radius, and we want to find the slant height, just like with the pyramid, we're going to have to use some Pythagorean theorem to get that to work. So keep that in mind. That Pythagorean theorem is always kind of present with these problems. The next one we have is the volume, and this formula is 1/3 pi times r squared times height. So notice the pi r squared, that's going to be the area of the circle. The height is not the slant height this time. It is the vertical distance from the center to the apex of the cone, or kind of like that point where they all go to. The 1/3, it happens just like what it did with the pyramid, where it was, 1/3 the volume of like a cylinder with the same base. So that same kind of situation happens here if we were to compare this cone with a cylinder of similar height and the same base. So with this one, 1/3 times pi times 3 squared, and then the height, we didn't even have to solve for the height. It was given to us, it's just 4. But again, keep in mind you might need to use that Pythagorean theorem. So the volume is, I typed in 9 because we know that 3 squared would be 9. So that's approximately 37. This one I'm not going to be able to round to 2 decimal places, so I'm going to go just 0.7. And that is feet cubed because we're talking about volume this time. All right, so very similar to the pyramid in terms of how the surface area and volume formulas are formed, but the fact that we get to use pi and radius, it just makes it easier, kind of like how the cylinder was a little bit easier than